All right. Recording started. So, you guys remember we are in chapter 15? I have a few more problems. I'd say at the mid next week, we're going to start the next chapter, okay? And that chapter doesn't have that much I have to cover. Or end of next week, okay? So that's the plan. Coming back to this problem again. This problem, you guys remember in last class, we had to deal with two things: linear of momentum, conservation of linear momentum, and conservation of energy. Those are the two things that we use to solve any of this problem here, okay? In last class problem, I don't know if you recall, one block is hitting at a speed. Do you remember in last class problem, one block is hitting at a speed to a standstill block, which is connected with a spring, and then both blocks were moving together, right? Stretching the spring. So we had to use two equations, right? One is the conservation of linear momentum, and another is the conservation of energy. Okay, in today's problem, we're seeing two of these train. You see here, here in today's problem, we're seeing two of these train are coming together to a speed, right? To rail car with a mass of 20 and 15 megagram. Guys know what is megagram? It's like 20,000 kg and 15,000, right? Okay. And velocities are shown like 3 and 1.5. Those are hitting each other. The speed of the car A after collision is that's what we're going to find. The speed of the car A after the collision if the car collide and rebounds such that B moves to the right. Okay, so this A has a high speed and A does have higher mass. So obviously it does have high momentum, right? MV is the momentum. So it'll gonna do what? If both hit together, this A will gonna push B or drag it towards the A direction. Does it make sense? So this is this thing. Okay, so you gotta find the speed of car A after collision. And rebound such that B moves to the right with the speed of 2 meters per second. Also, find the average impulse force between the cars if the collision plays in 0.5 seconds. You remember the impulse force multiplied 0.5 T. That's the impulse energy. Just remember FT. Okay, so that's F we gotta find. So two things: when both cars collide each other, right? That A car velocity after the collision, B car they said after the collision the velocity is 2 meters per second. Okay, A car velocity after the collision, right? All right, understand so far? Did you know? All right, so that's the first thing you gotta find. The other thing that you gotta find is the impact force F. Okay, so the strategy, you gotta use the conservation of linear momentum, just like in last class. Remember, in conservation of linear momentum, before and after the strike, you have MV. Okay, so before the strike, you have both MAVA, MBBV. Makes sense? M is the masses, V is the velocities for both A and B, those two cars. And those are, if you can put a subscript before the collision as 1 and after the collision as 2. Okay, so that's the conservation of linear momentum that we're going to apply to find what? To find the velocity of car A. Because take a look here. Out of those before and after for both cars, 4 velocities, 3 are given. Before, 2 velocities for A and B are given. After, 1 velocity for B is given, right? So you're going to find the velocity of A. And the masses are known for both of those blocks, right? Like train in this case. So basically, you just have to use that equation M1 V1 plus M2 V2 equal to M1 V2 plus M2 V2. Okay, something like that. You can put those names as your wish. Doesn't really matter. Bottom line, you got to find one unknown, which is the velocity after the collision for A. You got it? This is the first part, right? That's a strategy. Then, to find the velocity, an internal impulse sensor. Okay, then use the principle of impulse and momentum to find the impulsive forces by looking at only one car. Okay, remember the impulse force equation, right? So that's what we'll be using. Anyway, so that's the whole thing that we are planning to deal with today. Let's start with any question with the problem itself. Everyone understand? Dylan, you're good? All right, perfect. All right, let me start. So what are the givens? First of all, the masses for these two car, here the car means like the train car, are given, which is MA and NB, 20,000 kg. We're taking the class note, right? 15,000 kg. All right, so the initial velocities for both cars are given. Let me write them. So initial velocities. So which is what? VA PB. Now, as I said, like the subscript, you can put it like 1 for initial or I as initial. It doesn't really matter, right? So I'm going to put I as initial. So I as initial for both cases, right? And both of them, the velocities are given as 3 meter per second and 1.5 meter per second. Okay, the final velocities. How many final velocities is given? Just one, right? Which is for car B, right? Velocity. I'm going to write velocity because just one velocity is given. And I'll be putting subscript F for final, okay? I is for initial, I F for final. And that's the value is like 2 meter per second that was given. Okay, what you got to find? Write them. So find the final velocity of cart A, which would be BAF. Okay, and what else? You got to find the average impulse force, which is, if you guys remember, FT, right? But in this case, you see, you can write it like generic way, which is as if like you're doing the integration, okay, with F is a function of T, okay? But it is basically F multiplied T. F is the force, T is the time, 0.5 second given, right? You can say it like, in the givens as well. The impact time is given as 0.5 second, but it's fine. You can write it this way for now. Solution. You got to solve these two unknowns by using these two different equations. The first one is conservation of momentum. And I'm going to give you those equations and I'm going to let you solve it. If you can finish the solution, then you can go. Okay. I don't have any other agenda other than this problem today. We're going to possibly do 2 problems on Monday, okay? But Friday, let's go a little slow. As you can see here, I had the summations, and I and F is in the summation referring to obviously those both blocks initial velocities like BAMAI plus BBIMB. All right, and you should be writing MABAF MB. This is very straightforward, this part of this problem. MB, probably have done something similar. Okay, and then you're going to start to plug all the values. I'm going to just give you the final value here, which is VAF is 0.375 meter per second. All right, that's the first part you'd be solving. And the second one, let me write it next to it. So that one is impulse and momentum on car A. Okay, in X direction. You know X direction, it does have one direction movement, okay? What is that? It is MAVAI FDT MABF BAF. All right, so that one is so important. Let me highlight that. Looking at one car only, okay? That's the highlight here. So when you're doing the impulse and momentum on car A, you're looking at just car A, or you can look at car B, because remember, both of them, unlike the other problem, get separated. It just has the impact and both of them has independent motion, right? So that's why I don't have MB here on this impulse and momentum equation. Does it make sense? All right, so can you do that? Let me give you the solution. So the solution would be F dt 52,500 Newton second. Now, if you know, there's a given. I'd like to write the givens here. So collision time. So the time for collision is 0.5 second. Okay, if you know that, then can you find this another thing that would be like this is A, this is B. Can you find average impulse force? So this is like, impulse. The average impulse force, average impulse. This is average impulse force. Average impulse force is FABG. You find that value. All right, so which would be, you got to do further math, which is average. You got to multiply it by T, which is the T is here, right? This is T. And this is equal FTT. So if you're going to solve it, you're going to find this average is 105 kilonewton. All right, so rest is fill in the blank for you. See if you can finish it. So I have all the answers. I'm going to start giving you the solution one by one, but you should be trying by yourself. And if you can finish everything and understand the whole problem, you can leave. While you're doing it, let me recap the whole thing. What happened here? We have these two different cars for a train are moving collide with each other. The masses and velocities initially are given, and final velocity for car B is given. You're asked to find the velocity of car A. You just have to do this straightforward observation of linear momentum, where you have the masses and velocities before the collision or impact, and masses and velocities after the collision should be on the right side. And then from there, you can find the one unknown out of these four parameters, which is the final velocity of block A. And once you have that one, you can use it in impulse and momentum equation for card A only. Okay, and we use the card A only because after the collision, both cards get separated. Okay, that's the reason you have all the values. And happy Friday. Enjoy. All right. How many values you have chose so far? How many values you have so far? You have any result yet?
Again.
You on this?
Yeah.
How about you, Christian? Almost done?
Last one. I was checking to make sure.
Okay. How far you are? Almost done? Yeah. Gavin? Elena, you're doing good?
Yeah.
Random momentum. The dark Christian? Perfect. Happy Friday. On Monday, we're going to do two problems, okay? I just wanted to do live today after the symposium. Wanted to say hi to everyone. All right. Good day. Let me start solving the first one, okay? So the velocities. So I do have
all those values, like the mass is 20,000 multiplied by initial velocity 3. I won't be writing the units individually. I'm going to write the unit shortly after this. Just 1 second. So then the mass is 15,000 for block B. And then I have this velocity is in negative direction. You got to make sure the direction you are following. Okay. So that is negative 1.5. And that could be one catch here. Okay. So that direction should be negative. All right. All right. Okay. What I was saying. So then the unit is kg multiplied meter second, right? Okay, equal. So you have this 20,000. Till you got it? That is the catch. It should be negative. The thing is, in x direction, think this way. It's quite interesting. Say, take a look at it. What is happening? So this card is coming this way, this one is going this way, right? So this is positive direction, this is negative. Now, once they hit, both of them are going in the same direction. Does it make sense? So that is a little tricky. Now, I don't know what direction the A is going. The result is going to tell me what direction. But the B for sure is going opposite to B's initial direction, which is A direction, right? That's given. All right, so this 20,000 BAF plus 15,000 multiplied 2 . All right, so then I have this 20,000 BAF. I'm going to rearrange things from here to there. And then I have this 20,000 multiplied 3 plus this 15,000 multiplied 1.5. So negative 1.5, negative 2, right? Because these two are going to, anyway, you can do the math, but this is the way I prefer. All right, so then this BAF should be equal 20,000, and then you have this 60,000 minus 3.5 multiplied 15,000, and the whole thing is meter per second. If I'd like to write the units here, obviously, it's the same thing as like kg meter second. This one is only kg. Okay, if you do the math, it should be coming up 0.375, which clearly tells. That's the value you got? Everybody? All right, perfect. All right, so then the second one, you have this impact FDT is equal MAVAF minus VAI. All right, right? So you can get the value in negative, right? But you can do it absolute. Let me get the result, whatever way I'm getting. So 20,000 multiplied 0.375 minus 3. This is Newton second, and the whole thing you can do it as like absolute. Okay, because the impact is like the absolute, it doesn't have any direction, right? Everybody agree, right? Impact is absolute. Okay. All right, so once you have the impact, then you should be getting this value, obviously, and then you should be just plugging the value 52,500 Newton second and divided by T, which is 0.5 second, right? Should be F average, where I can put a side note here again in case if you forgot. T is 0.5 second. All right, and you should be getting this value as like 105 kilonewton, like 105,000. That's good. All right, I'll see you on Monday. Take good time, finish the class note. And what is happening here in this problem, two cars are colliding with each other with two different velocities, and finally they have same velocity in the same direction. Same velocity direction is same after the collision. Okay, that's the trick here to understand the whole problem. Okay.
When you took the integral of f, why is it absolute value just because it's force and
Yeah, it's the impact. Impact doesn't have any direction.
okay, cool.
Okay.
Thank you.
All right. We'll see you on Monday.